What is diffusion? Diffusion is a chemical term which is defined as the movements of atoms, ions, and molecules from an area of higher concentration to a lower concentration. Information diffusion is essentially the same. People make decisions in their daily lives on shopping, career, politics, and so on. Although it looks like we make these decisions ourselves, we're not isolated from each other, and other people have great influence on us. While face-to-face interactions used to be the primary communication tool in the past, today's communication happens mostly on social media. Therefore, social network analysis has become very important to understand the dynamics of opinion formation, change, and propagation. Many studies are looking for the answers to the following questions. How do people form their opinions? How do people influence others' opinions? And how does new information diffuse among people? For defining and modeling the collective behavior of groups, Schelling, Axelrod, and Granovetter developed the Markovian linear threshold model. Let's look at how the threshold model works. Suppose that opinions of people follow a binomial distribution. Gray nodes represent opinion 0 and black nodes represent opinion 1. People change their opinion if the average opinion of their friends exceeds their threshold. But how can we define thresholds of people in the real world? First studies on social contagion have used homogeneous or binary threshold models because it was simple. However, Granovetter suggested to use heterogeneous thresholds for individuals since all have different demographic and psychographic factors. Nowadays, more complex threshold models are used in social contagion studies. To understand thresholds of people in the real world, we collected approximately 30 million cybersecurity-related tweets. Although some of them are original tweets, almost 17 million of them are retweets. We observed that users who have more follower accounts are creating their own content rather than retweeting others' tweets. But what about the effect of their following count on retweeting threshold? To understand this, we get 3 most retweeted tweets in our dataset and divide Twitter users into 8 categories according to their follower and following counts. Results show that retweeting thresholds of users are correlated with both their follower and following counts. Therefore, we simulated 2 cases. In the first case, in degrees of nodes are constant. Every person has the same following count and thresholds are correlated with their out degrees. In the second case, every person has the same follower count and thresholds are correlated with their in degrees. Results show that in the second case, people generally reach a consensus more easily, but average opinion is very sensitive to the number of people and the mean degree of the network.